So the object of the exercise for the next few minutes is to get some practice at working out the value of fuse to use in specific situations. And so the heading is going to be fuses. And for this exercise we need to know also that the available values of fuses to use in circuits, in the live wire of circuits, there are only three of them: 3 amps, 5 amps and 13 amps are the only varieties possible. Now the example that we're going to go through is as follows, and you need to sketch the circuit diagram, which is going to be consisting of a 240 volt supply. That's an alternating voltage supply. It's a main supply of 240 volts, and we're going to connect into that a device whose resistance is 80 ohms, and the power rating will therefore be, as a consequence of that, 720 watts. You couldn't really get one without the other. It has to be 720 watts if 80 ohms is connected across a 240 volt supply, for the following reason. Since power is equal to the potential difference across the device multiplied by the current in the device, we can see that 720 joules per second is equal to 240 times the current. And the only value of current that will satisfy that equation is 3 amps. And the only way you can get 3 amps in a circuit like this is to connect 80 ohms across a 240 volt supply using V equals I times R. 240 equals 3 times 80. It's the 80 ohms that has to be connected across 240 volts if you want to develop a power of 720 watts. So there I've included the 3 amp value of current. It's alternating. That means the direction of the current is different over a long time. It changes every 1/50th or so of a second. And the question, of course, is, if you look at the heading, what on earth is the value, what on earth, not a pun, not on earth, what on earth is the value of the fuse that you use in the live wire? At the point I'm marking now, you need to put in a fuse, which is the live side of the circuit. What value of fuse to use, given the fact that we've only got 3 values that are marketed? And the answer, of course, is not 3 amps, not 13 amps, but 5 amps is the fuse to use, because you're using 3 amps when it's working normally, and so obviously a 3 amp fuse would burn out quickly, and a 13 amp fuse is too high, and you need to protect the walls of your building from overheating, because the wires that you are using for this circuit will get too hot. So I'm moving on now to a new slide. The system has to be that we need to be able to work out the value of current in a circuit, and having worked out the value of the current, then we look at the 3 values of fuses to use and then decide what is appropriate in order to protect the walls of houses from overheating and causing a house fire and destroying all your wonderful possessions. And the equations to use in order to find the actual value of current used in the circuit so that you can make that decision, there are effectively 2 of them. The very basic formula, V across an item is the current in that item multiplied by the resistance of that item, and the other one is that the electric power, which is the number of joules of energy per second, is the potential difference across multiplied by the current in. And those two formulae, used in a careful way in circuits or in questions to do with circuits, will always give you the right answer and all the marks for a question on this topic.